and welcome to this video. In the last presentation, we were able to calculate the load in kilonewton per square meters as per the capacity of the tanks in which we will be using to design the tank stand successfully. So this is what we have in the last presentations. And so if you are not in that video, you can take the video right in the description of this video. So we have 9.1 kilonewton per square meters right here. So we are now to assume safe weight of tank to be 1.5 kilonewton per square meter and assume life load to be 1.2 kilonewton per square meter as well. And so the 1.2 kilonewton per square meters cater for the human load that may be carrying out some activity on the tank, okay, in the platform successfully. So this we have to sum it to have a total area load on the platform in kilonewton to be 9.1 plus 1.5, which is 10.6 kilonewton per square meter. So this is going to be serving as the dead load, and while the live load that consists of the human load on the tank platform is going to be 1.2 kilonewton per square meter. So I will be taking you how we can design this tank in a unique way, all right, and then apply this load successfully, carry out the necessary loading combinations as well as design, analysis and design, and then we try to design to get an economical sections for this tank stand design successfully. And this is going to be a steel tank stand, okay. So we may progress. So after the summation, we have 10.6 and then 1.2 for live load and 10.6 for dead load. All right, so we want to be navigating into Protastructure so we can start the modeling. But by then, we have to save this our design, okay, this tank platform design, where we be saving it to DSF, so we import it into Protastructure. All right, so I'll be taking you step by step in these presentations on how to carry out this design successfully, and we proceed to Protasteel and to see how we can do the steel connection successfully. All right, so stay connected as we make progress. All right, so now this is the design. This has been explained successfully in the previous video, so you can also check that video. So we now key time in this particular video. All right, so now we will just have to select this platform that we have set out. All right, we select this platform that we have set out. We are not really concerned with the dimensions, okay, because we are not going, but we can select everything. There's no problem. Protastructure cannot understand the dimensions. Raft structure will only understood the grid lines successfully. All right, so we make progress having that selected. Type W on the keyboard and enter. So in this right block dialog, we will navigate to the desktop and be able to give this a name. All right, we'll give it the name as the tank design, tank stand design. Okay, so we have something like this tank, okay, stand like this design, okay. All right, so we are going to be saving it in DSF. So you click in these permissions, we'll be using DSF 2013. Okay, so just like this, you can select any other year, okay, there's no problem. So after save successfully, click on the OK option, but the instruction unit should be in millimeters because we have been considering millimeter in Protastructure successfully. So I click right there. So that has been saved on the desktop. So I want to navigate to Protastructure right away. So we continue from there. So here we go. This is the pattern of design we are going to be considering in this video. All right. So we are going to be creating a new project. So we get to the file menu right there, and then we select new project. This option right here, you click there. Okay. So in the new project, we are already having tank stand right there. So we will just have to place an iPhone there, and then we can just put the capacity of the tank 6,500 liters, okay, and right there, tank stand, we add design as well, okay, just like this, design, okay. All right, so we proceed to select the code of practice. We're going to be considering United Kingdom Euro code options. After select, you click on the OK options, and then you give the program some seconds to actually open an Euro code template for us to proceed with the modeling of the tank stand successfully. So now the template is ready. Okay, so we proceed to the building setup tab, and then we get to DSF. You click right there. So DSF dialog will come up, so we can be able to import the DSF we save to desktop from AutoCAD successfully. So come to load DSF, click right here. So we navigate to the desktop right there, and then we scroll down and be able to check for the file that we have saved right here. Okay, thanks to this one, you open it right there, give it some second to load successfully. All right, so it is still coming up. All right, so that is it. So what are concerned here, you can see is grid lines. Okay, is our concern, and then the import type is going to be floor plan. All right, so every other thing, leave it positive, and then click on the import. All right, so the process is completed, is being imported. Okay, so you click on close right there, so you can see it here. So here are the grid lines set out we did in AutoCAD. So after which we have to save the project. Okay, so having saved the project now, we will proceed to edit the grid lines. Okay, so for the vertical grid lines, we will be having it to be, label numerically. Okay, having that selected, we right click and then click on each property. So in the property dialog, we will now start to edit this. So where we have A2 is supposed to be 1. You click in 1 right there. Where we have A8 is going to be 2, right? And then A1 is going to be 3. Okay, just like this. And then A9 is 4. So A3 now is 5. Okay, after which you click in another provision and close this. So in the horizontal direction, we have it named alphabetically. So right click and click on each properties, and then we are naming it A from the bottom up. So A6 now is going to be A right there. Okay, it should be always in uppercase later. So A7 is going to be B. Okay, then we have A5 to be 3, C right there, sorry, and then 4 is going to be D. Okay, just like this. After which we are done with that, we start the modeling. But before that, we are going to be creating stories. For us to be able to achieve the design, we will have up to 3 stories right there. Okay, so for us to create a story, you can select on the stories right there, right click. Okay, you see a drop down menu here where we can use to set the story successfully. Okay, or you can come over to where you have stories operations right here. Okay, so you see the same functions right there. Okay, you can also use these provisions to get the story set successfully. But we'll pass through this process. Okay, so I will click on this insert story. Okay, so in the insert story dialog, you can see default story height is 3 meters. That wouldn't mind, we'll get to change that later. So you key in 3 right there, so we can be able to have 3 stories. I click on the OK options and the yes option. So the 3 story has been created. You can see we have 1, 2, and 3 right there. Okay. Okay, so but by then we are going to be saving this project. So click on save to save the project. Having saved the project successfully, we start to place the stanchions. But before then, we edit the stories. Okay, so editing the story, you have to right click and click on these stories right there. So once it comes here, okay, this story 1 is going to be 600, or we just made that 600. Okay, millimeters. Okay, then the depth of the foundations, it is going to be I will want the story 1 and then the depth of the foundations altogether to be 1.2. So I should have 600 here. Okay, so I have 600, okay, to have 1.2. Okay, but I will make sure I increase that so that it will be rigid enough. Okay, for making it rigid enough, I will make it 1.5 altogether. That simply means I have 600 here, so I should be having 900 right here. Okay, so for story 2, okay, the total time, the total stanchion we are going to be considering is going to be 4,500. All right, so 4,500, I'll be having 3,500 right here. Okay, for the second story. All right, then for the third one is going to be meters, which is 1000 millimeters right there. Okay, so this make up the total length of 4500, because the tank is going to be used for a residential bungalow building successfully. All right, so having make all these changes, click on the OK, but by then also check structural system to make sure it is ROC right there. Okay, these provisions. All right, we are not reducing any load, so we are not going to touch all of these imposed reductions provisions. Okay, so we click on the OK options right there. Having said that, successfully we navigate to save this project. Always remember to save your project. Go to the modeling tab, and then we select on the column, still column right there. So in the still column dialog, we have to navigate to set the sections successfully. So you click on the section manager. So in the section manager dialog, we will navigate to see how we can select the small section. We'll be using this UB. Okay, so we navigate to use 178.102 by 19 thickness right there. Click on the OK options, select that, and then OK. All right, so this is the first place we are going to be placing this. We're going to be placing the stanchion. So you placed it, pick at the grid line intersection, that point, okay, to have it placed successfully. So this AutoCAD set out, the link will be in the group chat. So if you are in the group chat, you will request for the AutoCAD file. Okay, so we will send the AutoCAD file to you. So if you are not in the group chat, you have to join the group chat through the link in the description of this video, and then request for the AutoCAD file of this set out. I will send that to you so you can practice as well. Okay, so we make progress. I have selected that the orientation of my column is fine. I want to go by this orientation, so I will pick this point to select to place the second column successfully. Okay, so having done that, there is something I did not do over lens story. It is not supposed to be at story 1 only. It's supposed to be extend through story 2. So let me show you what I meant. Okay, so you have to stay tuned because you will learn a lot of knowledge in these presentations. I will double click, right click here to navigate to the 3D of this, so you can see what I have. This is within story 3, and it is only 1 meter. Okay, I want it to extend through the other 3.5 meter that we have set successfully. So select this one, go the control key, select this. Okay, and then right click, click on edit properties. So in the property where you have lens storage, select in this provision, edit wise. Okay, and then come to this provision, key in 2 right there, click on OK. That has been extended successfully. Click on the OK option. So this is what you now have. So the total length of this tank stand, the height of the platform is 4500. You can see it there. All right, so this is what I actually intended. So the next thing we are going to be modeling is the beam, the crossed beam that will connect green line intersection A3 and then D3 right there successfully. So we do that in 3D, and then we navigate to the modeling. We have to save this project, all right, and then get to beam this time around. Click on beam. Okay, so in the beam dialog, we will also need to navigate to the section manager and then be able to get the subsections. Okay, you have that select, and then you click on the OK option. So we are going to be picking from this point all the way to this point. Okay, now it is asking us to split this. We wouldn't want to split it. Okay, you have to select no options. Okay, so you will split it, all right, and that will be placed successfully. You can see now it is placed successfully. I will close this. If I select it now, you see all is selected. It's not being splitted. Okay, so now we want to be taking the analytical line to the top of this stanchion. All right, so for us to do that, we have to offset this whole beam up to the top of this stanchion. So you double click on this beam, and then here we have the height of the beam, 177.8. So you click in these provisions where you have elevation I and G. You click in there 177.8 right there. Come over to this provision 177.8 right there. After we click on the update, so we have moved the beam on top, right on top of the stanchion. successfully. So we are going to be using these subsettings to draw other beams, okay, that may connect this particular beam successfully. Okay, so what you have to do now is we have to pick from that point and take it there, place it right there. Okay, so and then we wouldn't want to split this. Okay, we wouldn't want to split this. We don't have to click on no option to have it right there. So you can see the setting has changed. So we are going to be using the same setting 177, okay, 0.8 right there. Okay, then this provision 177.8 right there. Okay, click on the update to have this. So we take that all through. So right click to get rid of this command, and then these other provisions you select that 2 point. No, we really want it to split. So take it to these intersections and place it right there. Right click and then have another beam here. Okay, so we are trying to design the top of the platform now. So this is how it's supposed to be. Okay, so the next beam we are going to be considering is the beam on this line. So this is going to split. Okay, so I will take it all the way here and then I will split it. Yes, all right, it's being splitted successfully. This same thing here, I split this. Yes option to have that split successfully. So we are done with this. Okay, so we close this dialog. So this one we have so far. Okay, now we have the incline supports. Okay, so we are going to be placing the incline support successfully. So what we do, we use this column sections, we right click and then we click on the property of that column. That's what we are going to be considering for the incline support member. Okay, so we come to where we have less story. Now we change it to 1. Okay, and then we pick the first point just like this. Pick this insert point and then pick also this point and then click on the update. You see what we have? You can see. Okay, it's just that the orientation of the beam, is not what we actually intended. So we change the beam orientations by clicking in these provisions, rotate it this way. Okay, click on the OK and update. You can see now this is what we are not having. So this is actually what we needed. Okay, this is what we expect to have. All right, so having placed it right there, we'll do the same thing here. Pick this point, pick that, pick this end point right here, and then update just like this. Okay, and we proceed these provisions. Okay, you have to pick it right there and then insertion point, and you pick this point, then update it right there. All right, so you do the same thing here. You pick insertion point, pick that point, and then update it. Okay, so if you want to know the integrity of Protastructure, Protasteel, concrete design, okay, so you have to impose us, okay, to the link in the description of this video, and we will teach you from A to Z. Okay, you enroll in our master class, which is ongoing, and we will train you on how to use this program effectively. All right, so let us make progress. And we click on OK options or close the dialog. So we are going to be having the main top of the platform where we place the tank. So for us to do that, we will be using a channel section. So for us to be able to get a channel section, we will navigate to the purlins options. We pick the purlin options right there. So we pick the first beam and the second beam right there. So this will bring up the purlins dialog where we'll carry out 1 or 2 settings right there to be able to place the purlin accordingly. So the first thing we do right here, it is still booting, but we consider the spacing, which is 1000 millimeters right away. But this 1000 millimeter is much, so we are going to be changing this to 200 spacing. Okay, 200 millimeter spacing. Okay, so now we have something like this. We go to the sag rod. We wouldn't need sag rod, so insertion method option right there, we'll choose none, so we didn't have any right there. Okay, come to geometry option. So in this option, left cantilever, we'll be having that to be 450 millimeters, 450 millimeters. Okay, just like this. After which, I think we are good to go. Click on the OK options to have that installed successfully. So we have this provision. The top of this is where we have our installed successfully. Okay. After which, we will get rid of this command and save this project before we make progress. Alright, having saved the project, click on the purlins again and then pick the first one, the first beam, the second beam to have it placed by clicking on the OK options. This is what we are having. So this is the main platform where the tank, water tank will be sitting successfully. So here is our design successfully. We are done with this design. The next thing we are going to be considering is the column that will connect this tank stand to the foundation successfully. So we minimize this for us to insert that column. We will navigate to the story one. So at the story one right here, we click on the RC column. In the RC column section dialog, we will have a sections of 350. We go by 350 right there, 350. Okay, by 350. All right, just like this. We click on update and then you pick this point to have it insert, that point to have it insert. Okay, this is not properly changed. We need a 350 by 350. Click on update right there. Select this property and 350 as well by 350 millimeters. Update. So this is what we have. So you can now see that at the bottom of the foundation we have fixed support right there. Okay, so we are good to go. The next thing we will be looking at is to load this structure successfully. So to load this structure, so before we load this structure, we will be saving this project. After which, move the grid line to story 3. Alright, so at story 3 now, we will now have to navigate to the, where we have to navigate to the loading. Here in the loading, we activate the load cases and combination. So here, click on load generator. So in this dialog, we are not going to be considering horizontal load because we are not designing for an high-rise structure. Okay, so we are not considering horizontal load. We only deal with vertical load combinations. They are right there, and click on the OK option to have our combinations just like this. Click on the OK again. After which we will proceed to save the project and then load editor. So here is the load editor. Okay, so over here we are going to be considering, you can view some other options right here. Okay, but here we have to do with the load type that we are going to be considering in this design successfully. So alright, so the loading options I'm looking for is not actually here. This is full uniform load. We are looking for full uniform area load. Alright, so the option is not here, and it is because we did not add clouding on this. Alright, so we click on the OK option, so we can place clouding on the polyline successfully. Okay, so we navigate to the modeling and then we click on the clouding. You select the polyline. Here we go. Click on the OK option to have it placed. Select this provision. Click on the OK option to have that placed. So here is the clouding. So through this clouding, we can be able to apply loads successfully on this structure. So we get back and save this project. Loading tab, load editor. So here we go. you can see we have an option for full uniform area load. This one is what we are going to be considering. Select in these provisions, choose the cladding. You can see here are the cladding we are going to be applying this load. So select this full uniform area load option, and then we see everything has come up very nice. So at first we have the G load, which is the dead load. We have it to be 10.1 thereabout. So let's check that out in AutoCAD. So we have in AutoCAD calculations we have 10.6 right there. Okay, so we minimize this, and then over here we have it to be 10.6 kilonewton per square meters. You can see, having keyed in the load magnitude, we select all of this member to have the load placed successfully, just like this. Select in this provision, choose the live load. Over here, change it to 1.2 right there, just like this. Then select all of the member right there to have it placed successfully. Click on the update. So we have loaded this structure successfully. Click on the OK options to have it applied successfully. If you want to check and know whether this load is actually applied on the structure, get back to this load editor. Click right there. You can see all the load is being applied successfully on this structure. So with this, we can proceed to run analysis of this structure. Click on the OK option. Before analysis, we have to save this project. Okay. Having saved this project, we carry out some material settings. So for material setting, we go to the building setout and then click on the material right here. In this material settings, we will see concrete columns right there, C35. Okay, we click in these provisions to change the strength of this concrete. We will use 20/25 right there and click on the apply to all members. Click on OK. We are only considering the columns, and then the reinforcement we will use 410 for the sake of this design. Click in these provisions. This is for the foundation columns. All right. So for the sections we will consider, you can see here 10. We don't need 10 for column. We don't need 13 for column. 16, 20, and 25. The program will select between this selected area of reinforcement. Okay. The next member we have there, the next reinforcement we have there is the milestone, which is the links right there. We have 8 and 10. Okay. Every other one we get rid of it right there. Okay. That is it for the reinforced concrete column and the foundations of this structure. Click on the OK option. After which you click on the OK option again, and then at the foundations of this structure, we can also come over to this provision, select this, and then edit this. We could have edited that in the last editor. So we can also do that here. We need 12, we need 16, and then we need 20 right there for the foundation. Click on the OK option, OK again, and OK. Having done with that setting, click on the save option to get this saved successfully. Now we want to be carrying out the analysis, but by then we need to check this project for modeling error. So we navigate to the analysis tab, building analysis. So in the building analysis dialog, we navigate straight away to the analysis tab and then building model check. We want to actually see if this model has followed the rules and regulations of modeling a structure in Protastructure successfully. Click on start. Okay, we have 0 error. Simply means our model is good. We have done a very nice modeling. Click on the close options. So we get back to the building analysis and click right there. We have this warning. You can see this warning. Analysis can be carried out when all stories populated model with empty story cannot be analyzed. Okay, analysis cannot be carried out. I want to just phrase it again. When all story populated models with empty story cannot be analyzed. So in these stories that we created, there are some stories that are empty. I will show you that. Click on the OK options, and then we close this because we can't be able to run analysis. We have to populate that story. So let's check which of the story that is not populated. Okay, from what I'm seeing here, story 2 is not populated. So we need to populate story 2, this story. Okay, so what we just need to do is we are going to select this beam, right click and click on the property. We use it to place on this story successfully. Pick the first point, pick the second point right there to have the beams placed successfully, just like this. Okay, right click to get rid of that command and close this dialog. Okay, so having placed this, now we proceed, save this project first, and then we proceed to building analysis. Right there, let's see if the building will carry out, the program will carry out analysis now. So building analysis option, here we go. So we wouldn't want to design the members for now, we just want to analyze. So we click on building analysis. So build analysis in progress. We are going to observe it to complete so we can be able to see if there is any warning given to us successfully. So stay tuned. You can also check in the link in the description of this video. There are some templates that may help you in your structural detailed drawings. So you can get them in the description of this video successfully. Now analysis is completed successfully. We are now expecting the final informations. So you see what we have here, relative story draft exceed the limit. Okay, relative story draft satisfy the limit in direction 2, exceed in direction 1. So for the sake of this structure that you are designing, you have to overlook this. The reason is because you see this relative story draft is being calculated based on story, and since we have used story 1 to connect with the foundations, and then you see the height of story 1 is so small, that is why we are having this direction 1 not satisfy the limit. Okay, so this is not an issue. All right, click on the OK option, after which click on the OK right here. Now we proceed to check the members actually if they have passed design. So we can select this member, they click on this T member design option. So through this option we can be able to check and select new member for this particular stanchion successfully if it fails the design. So here we go, we can see what we have here. Utilization ratio is 0.8. Check for combined forces. All right, so none of this should fail. If any of this failed, it simply means the structural members has failed, and then you need to select section through these permissions. Okay, so this has passed and it's given us 0.87, which is good enough. So we can go by that section. Click on the OK options, check this other section, right click. You can also see option of still member check right here if you did not use this option here. So select here. So we still have the same view ratio magnitude. Click on the OK options. Okay, let's check the incline support member X1. So you have this 0.009. So this is too big. So we can change the section right here by clicking on change section. UB, we come to select this smaller section right here. Select that. Click on the OK. So now we have 0.01. You can see, click on OK option. So the same thing we will do to all of the members. So this is what we call design. Okay, we are now carrying out the design and then be able to make it economical. Because if you do not do this, if you use the previous section, which is this one, it simply means we are over designing. The over design is much. All right. So by reducing the section, we also reduce the cost of material. All right. So this we continue to do to all of this member. So stay tuned. We select this, come to still member design, and then come to change section. Select UB 1 to 7. Select that. OK and OK. All right. So for this one, the same thing we do. Close this dialog. Select still member design. Alright, so let's change this. Come to this project, we have the section existing here, this one. Okay, after select, click on the OK. Alright, so let's confirm that all the section has been changed successfully. Okay, all the section has been changed successfully. Now let's check these other sections. This one, double click on it. Sorry, use the member design check. So this is 0.5. So we can decide to change. You can decide to take this to 152 because we needed an economical design. This is 0.7. This is okay here. Alright. After which, you click on the OK option. So the same thing we are going to be doing for all the members. So select this one. Come to change section. UB. Use this one. OK option. And OK. OK again. And select that. Change section. UB. OK. Alright, click on OK option. So we have done changing that. Let's check the outer beam. So this one we have here, the outer beam is even much smaller. Okay, let's check this center beam. Alright, so we can use the same sections that we had for these other ones. Okay, so we come to change sections. We use this one for all of that. Okay, options and okay. Same thing applicable to these ones. So if you also check the deflection, you can see deflection has passed design successfully. Over here, everything has passed design very well. Click on the OK option. Alright. Alright, so we also edit this as well. Click on the change sections. We use this one. Click on OK. Select this one. Click on OK. Alright, at this point we are done with designing these sections successfully. Let's check the purlins. So we are going to click on check all option, this option. So you can check all the purlins. You see, all of the purlin has been designed. You can see the U ratio. And then the design statute has passed also. So we are supposed to change the section of this purlin. But in the case of changing purlin section dialog here, we don't have option to make that change successfully. But you can see the U ratio, it is far less than 1. So if you want to change your purlin section, you need to go to the purlin options to edit it again successfully. But we'll go by this for now. Okay, click on the close option. You can also check the second purlins, check all. You see everything has passed design successfully. Click on the OK option. So now we are done with designing the structural element of this structure, remaining the foundation column, which we will navigate to story 1, expand the column option, select column, right click. We will have to check that we have only 2 of each section, 350 by 350. Bash mode, column design option, select that, select all members, click on calculate. Alright, click on close option so you can see what we are having here. We have the U ratio, which is fine. Okay, close this right away. So now we are done with designing of the structural element of this structure successfully. What we now need to do, let's save this project, is to design the foundation. For us to design the foundation, we will navigate the green lines to the story 0. Right there, we get these 2 members selected. We don't need to select the green lines. Select only the columns. Right click. We'll be considering combined footings. These options. So select the options. The combined footing dialog will come up. Alright, so you can see the design that we are having. In the LS, we have 1100 millimeters, which is the width. The LY, we have 1600 millimeters successfully. If you come to the 3D view, you can actually see that we are having doubly reinforced foundations right here. So if you want to make it single, you can come to the rebar provision, uncheck this. You see what we're now having. So you can make it single. You can design it again to see if it will pass. Okay, so it has actually passed. Click on the OK options to have it placed successfully, just like this. So we are done with the design. So what we now going to be doing, let's say the project, we'll be taking this to Protek steel to carry out the steel connection design. So to take this to Protek steel, you navigate to the drawing and report tab. You see Protek steel here, click it once, and then you give it a little second, a little time to load. Everything imported successfully. You can close this. So here we have our project. You see we have our project here. So in Protek steel, we are not considering foundation design because it is a combined footing. There is a shift during the import at this foundation. So that is not our concern. Our concern is the steel member designed successfully. So we want to carry out the connections of this, of all of this member, and then we produce edited drawings. Alright, so we will be considering this done in the next presentation. As we are going to be stopping here, don't forget to like, do not also forget to subscribe, and stay tuned for the next presentation. Have a nice day and bye for now.